All right, we are back at Heartland Developer Conference 2016 here in Omaha, here with Matthew Renze. Sorry, even though I said that the first time, we'll do a whole bunch of names today. So thanks for jumping in here and being a part of the interview process today. Let's get to know you a little bit. Okay. Tell me where you're from, what you do, business, those kinds of things.
Okay, I'm an independent software consultant and data science consultant with over 16 years of professional experience building large-scale data-driven desktop server and cloud-based applications. I have double degrees.
You said that a few times, haven't you?
Yes, yeah. Got that.
You got that part
well
nailed. I like it.
I have double degrees in computer science and philosophy with a minor in economics, and my focus was on artificial intelligence and machine learning at Iowa State University. I'm an author for Pluralsight, an international public speaker, Microsoft MVP, an ASP Insider, and I've worked on some pretty cool open source software projects over the years.
Wow, that's a pretty impressive. Yeah, do you do anything else but technology?
I don't sleep. No, I'm just kidding.
I know people say that to me all the time. We create hours of video content, and like, hey, when are you sleeping? I don't sleep as much as I used to.
Well, you can automate a lot of these steps nowadays.
You can. Well, you're here. Let's talk a little bit about your session and. You came and you mentioned R, and that's R has really stepped up in popularity in the last couple of years. Definitely. And at first I was kind of like, I don't know, when we think about it, is that a little too heady? But you convinced me, and I think very, very well why you thought it was important. So talk a little bit about your session, and then let's kind of boil it down into a kernel of what you'd like to get through.
So I gave a full day workshop on practical data science with R. So it's essentially using the statistical programming language R in order to transform data into actionable insight, using the processes of data science, essentially things like descriptive statistics, so numerically analyzing data, things like data visualization, visually analyzing data. We built statistical models to do statistical inference, prediction, and then we learned how to handle big data with R, as well as built machine learning algorithms to use the machine learning models to make predictions about given new data. And then we kind of tied it all together at the end by building an interactive web-based application using a framework in R called Shiny to build a machine learning application that would allow users to go out to the internet and to drag sliders to interactively work with the data and get predictions back based upon the machine learning model they created in the previous demo. So it was a pretty comprehensive.
Is that something? I mean, what do I need to do to ramp up to something? How can I, if I wanted to participate in that course? What do I need to know going in? There might be some guys who've been writing code forever but have not been around R. What do they need to do? What's the barrier of entry?
Well, to put it simply, I gave the same workshop in New York City on Wall Street just a couple weeks ago to people that had no background in programming whatsoever. Several of the students had never written in a single programming language. With the workshop, we were able to get them up and running, working with R and building machine learning models by the end of a day. So, I mean, from zero to machine learning in a short amount of time. And now, mind you, you won't be a data scientist when you finish with this, and you won't be capable of implementing machine learning models in production, but you'll have the understanding of how machine learning models work. And I point to resources to develop those skills, which take quite a long time to learn how to do good machine learning, but get them in the right direction so that if that's something they choose to do, they can.
R is nothing new, but I think its popularity is coming on. Is that?
So R was originally based on a statistical programming language called S, which was invented at Bell Labs back in 1976. R came around like right in 1993, I think is when it was first open sourced. So it's an open source implementation of that statistical programming language S. And it became really popular here in recent years. It stayed kind of in academia and just hid out for a while with the statisticians. They were continuously improving it. But then there are some people that made it really useful, guys like Hadley Wickham, who actually went to Iowa State University, where I went to college as well.
Just down the road here, for those just down the road.
Made it significantly easier to use for things like data visualization, working with data, transforming data, cleaning data, those kind of things that were generally difficult tasks. So with the power that it has added to it here in the recent years, combined with this need for data science tools, the ability to take data and transform it into actual insight, which is a really, really valuable skill, which is in extremely high demand and commanding extremely high salaries in our industry. R really just kind of hit that sweet spot of the tool that allows you to slice and dice data, work with data extremely well with a minimal overhead, and it made sense to the statisticians as well. So it really fit that niche really well.
Yeah, can you kind of give me a real world example? Maybe change the names to protect the innocent at this case, or guilty, one of the two. But can you give me some idea of some things that you've seen where R has been used, and then what's been the return? What's the value in it at the very end? How have those models helped, or what kind of decisions have been made kind of based on those models that improved performance?
I've got a lot of ideas in my head, but I'm trying to think of one that would be a really good capture kind of the essence of it. And I don't know, obviously I can't mention any of the names for the companies that
Acme, yes,
implemented some of these things for.
business.
But for example, I've built, in the simple cases, you can just take R and you can use it to do very basic analysis of your data. So anything that you've got a data set and you just need to figure out, well, how is our data performing? How is our team performing, even in terms of like metrics that are gathered from like agile team data. But then you can even do more complicated things, up to building like neural networks to take. Well, let's see, what's a good example? For example, and I can't say that they're specifically using R, but they're using these same kind of technologies. Doing things like prediction of recommendations. So, for example, you watch these two movies. What movie are you most likely to watch based upon this information? In addition, you can do things like determine what the average temperature tomorrow is going to be based upon historic trends and based upon other information coming in. And I'm trying to think of another.
Could it predict fantasy football?
There is actually a book, a whole book called, I think it's like data science with sports or with baseball or something about predictive analytics with baseball. So the idea is to teach you how to do machine learning and like predictive analytics, but using data from baseball games. Essentially, it's just one of these things that sports people would find super interesting.
Yeah, well, we're recording this in the fall of 2016, and I just did my fantasy football draft last week. And I'm always kind of thinking, how can I make smarter decisions and what should I be watching for? And I think sports are a perfect,
Yeah, the idea, I think it's referred to as bracketology. The idea of applying statistical models, machine learning, and predictive analytics to outcomes of sporting events. Yeah,
we actually, we have a high school internship program, and we did brackets for the College World Series this year. I try and get the kids interested in all the stuff that's going on in town and stuff. And no betting, no money was changing us. And one of the kids wrote an algorithm and actually came in second or third. I think among 14 or 15 of us that did it. So interesting. Who knows, right? Some of that, it's still, it's chance, and it's weird. Sports are weird that way. But are there other kinds of
like applications?
I imagine when we think of large data sets, right? What have you seen come in?
Last year when we talked, you found it really interesting. I was working on a project at the time for a company that was doing intelligent power over Ethernet-based lighting. So at the time, I was building the brains of the system, and I switched over to build the kind of big data analytics part of the system. So we have a series of sensors in every building. We have a series of lights as well, too. We can collect massive quantities of data from these sensors. We ship it all up into the cloud. And then once we have it in the cloud in a massive data warehouse, essentially, we can then run analytics on these data in order to make predictions or to control the light in more intelligent ways. For example, if you've got light coming in, this window at this side, and you've got light sensors here, you can say, well, I don't need these lights to be 100%. These can just be 50, but these have to be brighter because there's less light coming in. And then you can also make predictions about, well, Joe walked into the building. We know his office is this office. Let's do pathway lighting in order to light the paths that we know he's going to most likely go to based on his prior history walking through the building. So there's a whole slew of different scenarios you can use these kind of tools and technologies for. And I've implemented R, like machine learning models for various projects of my own as well, too.
When we think of the Internet of Things world we live in now, and I think of companies like Ecobee or like Nest, who creates thermostats, or the sensors, now we have lights that also have sensors in them, or motion sensors, or some of those things. Do we see, maybe you don't have the average user doing this, but the companies that are creating these, is this a space where they may do some predictive analytics to kind of help change the temperature of my house, or some of those things?
So there's this idea that the combination of a few technologies, a few key technologies, the idea of IoT, the Internet of Things with all these sensors, the combination with that with big data, so this aggregation, the ability to work with large quantities of data, and machine learning, the ability to use these data in order to make predictions about what's going to happen next, will kind of close this loop and create what I've heard referred to as cyber physical systems. This idea that will exist in an environment that's completely autonomous. Like, there's no human intervention necessary in order to maintain these systems around us. They essentially report when they're not working properly. They also maintain all of the things without human intervention to essentially function without the need for us, essentially, which hopefully will free us up to be able to do things that we find more interesting. However, there's also a bit of kind of scariness with this as well, too, because if you look at the #1 occupation in the majority of states in the United States right now is semi-truck driver. And we have a series of companies that are scrambling right now to build autonomous semis. Some are predicting they'll be commercial within the next 5 years. And when you recognize the kind of the labor costs involved in semi-truck, the transportation, there's a lot of like financial incentive for these companies, these logistics companies, to reduce their costs by implementing autonomous semis. So that has pretty fundamental changes on our economy. And we're not talking this is like 40, 50 years down the road. This is like in our lifetime, this is going to happen. So, there's essentially a whole slew of different things that we have to consider as a result of implementing these kind of artificial intelligence and machine learning technologies.
Yeah, I just saw farming is in the same category.
Autonomous tractors.
Yeah.
I've got some buddies that work for John Deere's Intelligent Solutions Group. They do some pretty cool stuff.
So the farmer now becomes more of a delegator from, okay, I'm going to put these tractors out at this time and do these things, and they're managing, the farmer's managing the equipment instead of being in it, right, controlling it. Less, I'm assuming less people, more work. We saw a little bit of that. It's funny, we saw a little bit of that in that movie Interstellar. Right, and you'd think, oh, that's a ways away, and actually, I think we're a decade, maybe less than a decade.
And I hate to make predictions like that because this will still be out there 10 years from now. People will be like, Renze predicted such and such, and it totally didn't come true. But given kind of how technology is progressing in an almost exponential rate, because productivity enhancing technology feeds into itself. So we see things moving faster in the future than we do in the past. So my guess is it's probably coming a lot quicker than we expect, just based upon our own intuitions about how things have happened in the past. But the thing that I think is really interesting about this is, well, actually, I forgot what I was going to say. I apologize.
Let me throw this in. It'll come back to you. One of the interesting facts I think we find about farming versus or even truck driving is that that will pave the way to the automobile, I think.
Yeah.
People are having trouble making a jump from self-driving cars, but I think we're going to see self-driving semis and tractor equipment or farming implement. People will get more and more comfortable with that, and then I think self-driving cars will come right behind
what
it.
I think will really be the selling point for that is the fact that the reliability or the safety ratings of the autonomous vehicles are still significantly higher than human drivers if you aggregate all the data. So the insurance companies really want this to happen. The governments probably want this to happen. I mean, less drunk drivers on the road. There's a whole lot of social welfare benefits from having fully autonomous vehicles, provided that the vehicles maintain a safety rating better than humans. That's all they have to do. It has to be better than humans, and we don't want people lobbying against this moving forward because it's inevitably going to happen. It's just how quickly will it happen. And what we hope is that this is going to free us up in ways that make society better, but it also has the potential of having negative implications as well, too, if we don't prepare for these kind of things, because that's a pretty decent shift in our labor economics when we have that kind of displacement of labor. So hopefully we'll be well prepared for it and know what to do next.
Hey, no, I would get in a car and let it drive. If it got me there, I get a book out, and there's a lot more productive things than I could be doing than putting my foot on the gas pedal.
Like doing podcasts while you're driving your car.
There you go. That will be awesome. Future of when we think about predictive analytics are just a piece of that. It's just a tool. But as you look ahead to the future, we've talked about some of the outputs. In other words, when we do machine learning but within this industry, within this code base, within this what we're doing here, what's the future next couple of years?
The next big thing. So right now, within the last few years, we've seen a big, how do I word this? So deep learning, deep neural networks have really revolutionized the way machine learning algorithms work in terms of their accuracy and predictive capabilities. In fact, machine learning algorithms with these deep neural networks are now better than humans at several categories of activities that humans have always beat computers at. And so we're going to see a whole new slew of activities now that will be automated because of these deep neural networks. And there's even people that are predicting that this deep learning will lead to more of a generalized, some people refer to it as a universal learning algorithm. I'm not as optimistic that this is going to happen. But I mean, we know the human brain works really well at solving a wide variety of tasks, and the deep learning models that we have, which are gross approximations of the human brain, they're oversimplifications, like very simplified versions, but they seem to be capturing kind of the same essence, this idea of hierarchical feature extraction, the idea of pre-training allows us to settle these neural networks, deep neural networks, into better local minima or better states, essentially. I think the deep neural networks are going to be the big thing that drives a lot of new technologies forward, and the thing to really keep an eye on. In fact, we just saw just about every major company that has a deep learning has open sourced their deep learning toolkits within the last few months. It's all just Google has with their TensorFlow. We've got Microsoft has. I'm trying to think. Facebook has.
Does Watson
several.
fit into this? IBM Watson?
Watson, to my knowledge, is an ensemble learner. So it's a collection of a bunch of, how do I want to word it? I don't want to say not super smart, but rather than building one really smart algorithm, you have a bunch of just kind of normally smart algorithms and use the concept of essentially wisdom of the crowds to get an aggregate guess as to what is the correct answer. And so then all of these little algorithms perform better than an expert algorithm in many categories of reasoning, but it doesn't work well for all categories.
Yeah.
But I heard, and once again, I hate to say these things out loud in case it's wrong, but I heard that Watson is now actually better than any human doctor on the planet at diagnosing diseases. So whether that's true or not, we have to look.
Well, even if it's not, I think it's getting close, and it's amazing some of those pieces that we have coming.
Yep.
You know, the question will be, I think, politically and from a human standpoint, will we be able to handle it? Like, will it be something we'll be comfortable with? And I mean, I have no problem standing in front of a scanner and it doing some things, and then a robot doctor saying, hey, these are the things that we see, and this is some stuff that you want to do. That I know guys go to hundreds of hours of medical school to be able to figure that out, but it is a little bit of learning. And they just repeat it.
And the thing that we have to keep in mind, though, is that, so for example, with the autonomous vehicles, a human being gets, 60 years or so of their life in order to learn how to drive a vehicle. And so they learn from every one of these experiences that they've had. However, these autonomous vehicles have the ability to share knowledge. So rather than one human driver learning over 60 years, we have thousands, if not hundreds of thousands to millions of drivers all exchanging knowledge as if it's a single kind of brain, so that any of these weird situations that you're not going to run into, like you're on a curve and there's a signpost here and then a deer runs in front of you while a pigeon flies by your windshield. Like a human might have that happen once in their lifetime. But if one of these cars has it, now every one of these cars has that knowledge in their.
And by the way, the human wrecks every time.
I don't think I could handle that situation.
Every single time. Well, but you're describing the board, right? I mean.
Yeah, no, we got to be careful, because that's one of the versions of society that probably doesn't look all that favorable. Depending upon your personality type, it might. But, and I try keeping optimistic, but yet, how do I want to word it? I'm skeptical in certain ways, but I'm optimistic in others.
We continue to get closer and closer to that point when we think about artificial intelligence, where we're going to have to make some real decisions, right, about what it can and can't do, and how we'll protect it. And how we'll protect ourselves from it.
And we have some very intelligent people that are helping us make these decisions, especially with the recent movement to weaponize machine learning and artificial intelligence and build robots that essentially would have drones that have the ability to choose whether a person is a target and to attack or not if they're disconnected from a human authority figure or whatever. And so all of the experts and people that I read their textbooks when I was in college, I've interacted with several of them. They all seem to be on the side of, no, this is not a good thing. We should never allow a machine to make a decision that's life or death in this context. But when you're driving a vehicle, this question is inevitably going to come up, and it's going to have to decide: do I kill my own driver and save a bus full of children, or do I hit the child? Or, well, I guess a situation where you're choosing between these two equally difficult things to choose. A real moral dilemma in the most pure sense.
There might be three dilemmas: one way hitting a child, two hitting the bus, or three taking yourself out. In that, and
who wants to buy a car that would kill you in that situation?
So as a data scientist,
and I'm not a data scientist. I'm actually a data science consultant.
Okay. How did you have to deal with these ethical issues and what you're working with, or do you kind of stay out of that?
No, it's mostly just political issues. Never any life or death kind of stuff is what I do.
Well, a day is coming, and it may already be here, I think, when we've got some of those ethical issues that have to be asked. And so Matthew, thank you for taking a few minutes to join me. Always good to have you on here, and we'll say thanks for listening. Hang tight.